So now that we have formulas for sums and differences, how about if we want to multiply? How about if we want to do, for example, the cosine of 2 theta, right? What would that be? Well, the double angle formulas are actually very straightforward to derive. Here's what I'm going to do. I'm going to start with my cosine formula. Cosine alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. Okay, well, look, do this. Replace beta with alpha. All right? Replace every beta with an alpha. So this becomes cosine alpha plus alpha equals cosine alpha cosine alpha minus sine alpha sine alpha. And now just simplify. Alpha plus alpha, this is cosine 2 alpha, and that's what I was looking for, equals cosine squared alpha minus sine squared alpha. And that's it. Right? That's it. There's my formula. Like I said, I'll let you work through the sine and tangent ones. You do them exactly the same way. Take this sine alpha plus beta formula, replace beta with alpha, and just do some simplifying. Right? And I'll summarize all of these on the last slide, so you do have them all together. Now there are two alternative forms of this that I want to talk about because we're going to need it in a minute, and they are generally useful. Suppose I go to my Pythagorean identity and I say, look, cosine squared alpha plus sine squared alpha equals 1, right? Okay, well that means that sine squared alpha equals 1 minus cosine squared alpha. Okay, well how about if I put that into my formula? Then this becomes cosine 2 alpha equals cosine squared minus, and mind the parentheses here, 1 minus cosine squared. And if I simplify that right-hand side, this becomes excuse me, need a little more room there. This becomes 2 cosine squared alpha minus 1. Right, so that is also cosine of 2 alpha. It's just an alternative form, right? Sometimes that's going to be convenient for us to work with. And now let me just for completeness, let's do the obvious next thing. Suppose instead of solving for sine squared, I solve for cosine squared. Right, then this becomes cosine squared equals 1 minus sine squared. And I can do the same substitution. Cosine 2 alpha equals 1 minus sine squared minus sine squared. And that is 1 minus 2 sine squared alpha. Right? Just different forms. Right? Sometimes one will be more useful than the other. What kind of makes these generally useful is these alternative versions, they only use one trig function, where the other one uses 2. Right? Our original one uses both cosine and sine. Each of these only use either sine or cosine. Sometimes that'll be helpful. Okay, so those are our double angle formulas. How about half angle formulas? Look, to do half angles, hold on to this identity right here. Cosine 2 alpha, right, equals 2 cosine squared minus 1. That's actually going to where I'm going to start. Cosine 2 alpha equals 2 cosine squared alpha minus 1. Right, let's start there. Now, the formula that I want is the cosine of alpha over 2. Okay, so here's what I'm going to do. do a little substitution. I'm going to replace alpha with beta divided by 2. Right? Let's see what happens when I do that. This becomes cosine 2 times beta over 2 equals 2 cosine squared beta over 2. And that's nice because that's what I was looking for, right? I wanted a cosine in here. Minus 1. So now all I have to do is solve this for cosine beta over 2. So add 1 to both sides. I get 1 plus, and you notice that the 2's, they cancel here. So this is just cosine of beta equals 2 cosine squared beta over 2. Let's divide by 2. Cosine squared beta over 2 equals 1 plus cosine beta divided by 2. And now take the square root of both sides. And I'll have my formula. Cosine beta over 2 equals plus or minus. You got to have that plus or minus. Sign is going to be an issue here. When we divide an angle by 2, sometimes it's going to move it into a different quadrant, right? And in a way that's going to make us have to be really careful about the signs. So square root 1 plus cosine beta divided by 2. And that's it. There's my formula. Okay, now again, I'm going to let you do the sine one. You're going to do a very similar process. And to get the tangent one, you do what we usually do with the tangent. Just divide the sine formula by the cosine formula. All right. So there's our new formulas, and I've summarized them here, right? Hopefully you stopped and worked through these on your own, right? But I've got the sine and tangent double angle formulas here for you, right? They are that sine one looks a little different from the cosine, right? But that's just how it works out. And you notice over here with the sines and cosines, the only difference is this sign here on the inside, right? Other than that, the formulas are identical. Okay, so what are we doing next? We'll see how we can apply a few of these, right? Do the same thing we did with the sum and difference formula. See if we can work through some examples of how they're used.